welcome to another video of Smarty Academia International. Today's topic is going to be on arithmetic sequence and series. Let's talk about what are the characteristics of an arithmetic series. First of all, an arithmetic series has a common difference, which is always same for each next term, and we call that as D. Consider an arithmetic series whose first term is 1, second term is 5, third term is 9, and fourth term is 13, and so on and so forth, until UN, the nth term. In this case, if we notice, the common difference between each two terms is positive 4. We can move on to the next term by simply adding 4 in the previous term. This is the characteristic of an arithmetic series, that the difference between two consecutive terms must be same, which means if I say u3 minus u2, which is 9 minus 5, which is 4. If I say u2 minus u1, which is 5 minus 1, which is also 4. So this must be same for each two consecutive terms. Please note that for the terminology of the term, we are going to use u. So u1 means the first term, u2 means the second term, u3 means the third term, u4 the fourth term, and so on and so forth. Now I would like to write these terms in a different way. The reason being is we want us to get us through towards the journal term of the arithmetic series. I can write the first term as 1 plus 0 times 4. The second term as 1 plus 1 times 4. You can see 4 times 1, 4 plus 1, 5. The third term as 1 plus 2 times 4, 4 times 2, 8 plus 1, 9. And the fourth term as 1 plus 3 times 4, and so on. Now using this, I want to see how I can write my nth term. Let's try to have a certain rationale or logic behind that. If you notice, these terms are always same for each term. 1 and 4 is continuing, where 1 represents your u1, which is 1, and 4 represents your common difference as 4. So that's something that's not changing. The only thing that's changing, if you notice, is this term, this particular term. And how is it changing? There is also a logic behind that. See, for the first term, my n is 1. For the second term, my n is 2. For the third term, my n is 3. And for my fourth term, my n is 4. And if we want to check this, if my n is 1, this is 0. My n is 2, this is 1. My n is 3, this is 2. My n is 4, this is 3. And if I want to write the same thing here as well, so I can write 1 plus and same thing as 4 here, whereas you know that my n here is going to be n, the nth term. I'm going to write n minus 1 because it is 1 less than the term that we are trying to find. So this is what the logic is, and we know that this is the first term, this is my d, and this is my n minus 1. So how can I write my nth term? Un will be basically u1 plus n minus 1 into d. This is what we call the general term of an arithmetic sequence. And this is something that's really important, and we can find any term using this particular formula. For instance, I want to find the 10th term of the arithmetic series, this particular arithmetic series. So I know that my u1 is 1 for the series. I know my d, the common difference, is positive 4. All I need to do is substitute n equals to 10 to find the 10th term. So u of 10 will be equals to u1 is 1 plus n will be 10, so 10 minus 1 times d is positive 4. Beg your pardon. So this will be equals to 1 plus 9 times 4. This is basically 1 plus 9 times 4 is 36. The answer is 37, which means that my 10th term of the series is basically 37. So this is how we can find any term of the series using this particular formula. The next thing that we want to find is the sum of the sequence. The sum of the sequence can be represented by two symbols. One is S of n, and the other is the summation, which is basically the symbol for the sum operation in mathematics. Both these symbols represent the same thing, which means the sum of n terms, u1, u2, u3, until un. Now, the general formula for these things can be written as n equals to summation, n equals to 1 to n of un is basically equals to n over 2, u1 plus un. This is the general formula for summation of n terms. For instance, if I want to find the sum of the first 10 terms, which is S10, this is equals to, from n equals to 1 till 10. Remember, this is my starting point in the summation, and this is my ending point where I want to end, from the first term to the 10th term. Un will be simply equals to 10 over 2, u1 plus u of 10. So all I need is the first term and the 10th term. Now this formula can also be restructured using my journal term formula for the arithmetic series. Remember, my un is equals to u1 plus n minus 1 into d that we just derived from the previous explanation. Now, in this un, here, if I find the un, I can simply substitute this equation in the formula. So Sn will be equals to n over 2, u1 plus, so this un will be replaced by this thing, so u1 plus n minus 1 into d. By simply simplifying it, you can get u1 plus u1 will be 2u1 plus n minus 1 into d. So this is another formula for the sum of the sequence, including this formula. You would notice that both these formulas have different utilities as we move on into our examples and questions. For instance, if I wanted to find the sum of the first 10 terms of the series, 1 plus 5 plus 9 plus 13, the same thing that we were doing it, and I wanted to find the sum of 10 terms, all I need to do is just use any of these formulas. One of them would be 10 over 2 u1 plus u10. Now please notice that I do not have the tens term in this case, but I can use the second formula, which is basically 10 over 2 2u1 plus 10 minus 1 into d. You will notice that I have both u1 and d, which I can substitute and find the sum of the first 10 terms. In this case, my u1 was 1 and my d was positive 4. So in this particular example, the second formula has more utility for me. The first formula can be used when I have both the first and the last term that I want to find the sum for. So s of 10 in this case would be basically 10 over 2, 2 times 1 plus 9 times 4. And if I want to simplify this would be basically 5, 2 plus 9 times 4 is 36. So this is basically 36 plus 2 times 5. The answer is 190, which is the sum of the first 10 terms. Start. Now let's consider some examples for arithmetic series. The question says, consider the sequence 8, 13, 18, 23, 28, and so on. The A part says that show that the sequence is arithmetic. I told you in my previous explanation that for arithmetic series, we must have a common difference, which means u4 minus u3 should be equals to u3 minus u2 should be equals to u2 minus u1 equals to t, which means all of these things must have the same common difference. Let's try to put the sequence under the test. So let's say I do u2 minus u1, which is basically 13 minus 8, the answer is positive 5. Let's do u3 minus u2, which is 18 minus 13, which is also positive 5. Let's say we do u4 minus u2, which is basically 23 minus 18, which is also positive 5. So you would say that the sequence has a common difference. Hence, it is arithmetic. So this is pretty straightforward. And this is how you will put your sequence under test whenever you get this type of question. The P part says, find the formula for the journal term. We've already derived the formula for journal term, which is un equals to u1 plus n minus 1 into d. Using our A part, we've already calculated our d, which is positive 5. The u1 is the first term, which is 8. Remember, whenever you want to find the journal formula, the only variable that you must have in your journal formula expression is n. So n remains as it is. So un will be equals to 8, which is the first term, plus n minus 1 into d is 5. Now, what you would simply do is simply multiply 5 with both of them. So what's going to happen? My un will become a plus 5n minus 5. Now, you can just simplify the algebraic expression, and your un will be equals to 8 minus 5 is 3 plus 5n. And this is your journal term of this particular arithmetic sequence. In the C part, it says find the 42nd term. Now, we can use our journal formula, which we derived, un equals to 3 plus 5n. The only thing missing in this particular thing is the n, and as we want to find the 42nd term, which means 42, in this case, my n will be equals to 42. So u of 42 will be equals to 3 plus 5 times 42. And if I calculate 5 times 42, it turns out to be 210. And simply adding 3 with it, it will be 213, which means my 42nd term of this arithmetic sequence would be 213. In the D part now, it asks you whether each term is a member of the sequence, which means we have to check whether 153 and 4067 is part of this arithmetic sequence. Now, in this thing as well, we can use our journal formula and try to find which term it is. And we know that our term must end up in a whole number, because you cannot have 1.5 term or 1.3 term. It must be an integer. If your n turns out to be an integer by putting these things into our journal equation, then this is part of the sequence, else it's not. Let's see how this works. We know that our journal term that we derived from our P part is simply 3 plus 5n. Now we want to find whether 153 is part of the sequence. So in this case, we will simply put un equals to 153. Now, let's try to find the value of n if this n can come down as an integer. So 153 is basically equals to 3 plus 5n. Now we just simply solve this expression for n. So this will be 153 minus 3 equals to 5n. So 150 equals to 5n, and n is simply 150 over 5, which is basically 30, which means that my 30th term is 153. So which means 153 is part of arithmetic sequence. Now let's try to find the second thing, which was 467. Similarly, I will use the same method, un equals to 3 plus 5n. So I'm going to use un as 4067. So 4067 equals to 3 plus 5n. I'm going to solve this using the same method. So 4067 minus 3 equals to 5n. So 4067 minus 3, if you see, it's 4064. And if I try to find n, it's 4064 over 5. And it's clearly going to be a decimal, because it's clearly not divisible by 5, 812.8. So you would say that 4067 is not part of arithmetic sequence. Now let's try to do another question. It says the first 4 terms of an arithmetic sequence are 51, 45, 39, 38. It says in the A part, write down the common difference. If you see in this case, the sequence is decreasing. It does not matter whether the sequence is increasing or decreasing. The only thing that matters, it must have a common difference. For instance, in the A part, if we look, our common difference, as it's already said, it's an arithmetic series, so we do not need to check if the sequence has a common difference. We can just calculate from subtracting any 2 consecutive terms, because it's already mentioned it's an arithmetic series, as compared to our previous question where we had to prove it. So D I can find by just simply subtracting any 2 consecutive terms. Let's say I do it by using u2 minus u1, which is basically 45 minus 51. The answer is negative 6. And if I do this for any other term, let's give it a try. u3 minus u2. So it's 39 minus 45. The answer is still negative 6. In this case, the common difference is negative 6. It's negative, and it's completely normal. If the common difference is positive, it means the series is increasing. If the common difference is negative 6, we'll see that the series is decreasing. Or in other words, converging or diverging. Converging means it's converging to a lower number, and if it's diverging, it means it's diverging to a higher number. But this is more relevant for geometric series. We do not use this for our arithmetic sequence. Now, in the B part, it says find the second term, u20. 20th term, beg your pardon. So similarly, we have a general formula for arithmetic series, un equals to u1 plus n minus 1 into d. In this case, we know our u1 is 51, and our d, as calculated from the previous part, is negative 6. All we need to find is the 20th term, which means n equals to 20. We'll put all these variables in this equation. So u of 20 will be equals to u1 is 51 plus 20 minus 1 times negative 6. This will be 51 plus 20 minus 1 is 19 times negative 6. And if I do 19 times negative 6, I get negative 114. And I simply add 51 with it, and my answer becomes negative 63. It's completely normal to have your arithmetic sequence or series as negative as it's decreasing, so naturally, at some point, it will pass across 0 and go into the negative domain. The C part says, find the sum of the first 20 terms. Now, in this case, if you remember, we had 2 formulas, as I said, n over 2, u1 plus un, and the second formula was n over 2, 2u1 plus n minus 1 into d. Now, I told you, you have to find the sum of the 20 terms, and you have the 20th term, which means this formula has more utility in this case, because I have the 20th term. So simply my s of 20 will be equals to 10 over 2, which is the value of n, 20 over 2, which is the value of n, and u1 plus u of 20. And if you notice, you have both u1 and u20. So 20 over 2, my u1 in this case was 51, and u20 in this case was negative 63, use a bracket. Now, 20 over 2 is 10, 51 minus 63 is basically negative. (20 over 2 is 10. 51 minus 63 is basically 12, which is negative 12, and the answer is negative 120. This is the formula for the first 20 terms. Now consider another example. It says, consider the arithmetic sequence 7, 10, 13, 16, 18. Write down an expression for the sum of n terms Sn. In this case, we want to find the general term. It means, and I told you, that the only variable that should be in the general term is n, and everything should be substituted. So we can use this formula, n over 2, 2u1 plus n minus 1 into d. All we need to find is my first term and my common difference. So my first term clearly, in this case, is 7. And my common difference, as it's already said, is arithmetic sequence, so we don't need to check. So I can just subtract 2 consecutive terms. Let's say u2 minus u1, which is 10 minus 7, which is positive 3. And I just need to substitute it here. So s of n equals to n over 2, 2 times 7, plus n minus 1 into d, which is 3. All I need to do is just do a bit of algebra, multiplying these two here. So my s of n will become n over 2, 7 times 2 is 14, plus 3n minus 3. I can simply simplify this, n over 2, 14 minus 3 is 11, plus 3n. So this is my journal term. You can also expand it if you wish. It can be 11n over 2 plus 3n squared over 2, or simply 11n plus 3n squared over 2. That depends which form you're more comfortable with. Now, the B part, it says, simply find n such that s of n equals to 140. This is what do is find n for which s of n equals to 140. And in this case, this is much more valuable. So what we will do is s of n equals to 11n plus 3n squared over 2. So what is my s of n? My s of n is 140, so equals to 11n plus 3n squared over 2. Now, this looks like a quadratic equation that we need to simplify to. So if I multiply 140 by 2, it becomes 280 equals to 11n plus 3n squared. If I bring this thing here and just simplify and write it in the general quadratic form, this will turn out to be 3n squared plus 11n minus 280 equals to 0. Now this is a simple quadratic formula which can be solved using your technology. If I simply use my quadratic formula or simply put this into the calculator, which I will be giving the tutorials how to use the GDC calculator or the other calculators to find these quadratic equations, you can simply find that your n has two values as naturally quadratic equation would give you, unless it has two real roots. So n1 will be 8 and n2 will be equals to negative 11.66. First of all, this is not possible. Neither n can be negative nor it can be in decimal form. So this is not possible. So the only n that is possible is 8. So n equals to 8, which means that s of 8 equals to 140, which means the sum of first 8 terms is equals to 140 for this term. Now let's do another question, which is a bit more tricky as we move downwards to different questions. In this question, it says an arithmetic sequence has terms u7, the 7th term as 1, and u15, the 15th term as negative 23. It wants you to find the first term u1 and common difference d. Now u7 equals to 1, u15 equals to negative 23. Now all we need to do is substitute these two things in our journal formula, which is un equals to u1 plus n minus 1 into d. Remember, we don't have any information on u1 or d, which means you will make two different equations and solve them simultaneously, as naturally we have learned that when we have two variables, we need two equations to solve it. So u7, in this case, n equals to 7, and my u7 equals to 1. Let's substitute this in our general equation. So my u of 7 will be equals to u1 plus n minus 1, remember this n is 7 minus 1 into d. u7, as we know, is 1, so 1 equals to u1 plus 6d. This is my first equation. The second equation I can find is just substituting n equals to 15th, where u of 15 is negative 23. So u of 15 will be equals to u1 plus 15 minus 1 into d. u of 15 here, as we know, is negative 23 equals to u1 plus 14d. This is my second equation. Now, if I simply write these two equations on top of each other, let's say I have negative 23 plus equals u1 plus 14d and 1 equals to u1 plus 6d. I can simply subtract these two equations, which means I will just simply change my signs. What's going to happen? u1 is going to cancel out, which means I can eliminate one of the variables. This is what we call the elimination method of solving simultaneous equations. You can refer back to my simultaneous equation videos for this. Negative 23 minus 1 is negative 24, which is equals to 14 minus 6 is basically 8d. And from here, we can find the value of d. So negative 24 over 8. So d is equals to negative 3. This is what we have found. Now to find u1, I can substitute d in any of the equations. Let's say I'm using equation number 1. So 1 equals to u1 plus 6d. And my d I know is negative 3. All I need to do is just substitute this value of d here. So what's going to happen is 6 times negative 3. So this is going to be u1 minus 18, which is 1. And simply, you're going to take negative 18 to this side. So 1 plus 18 equals to u1. And your u1 is turning out to be 19 in this case. So the first part has been solved. This was a much trickier question, but not that it's difficult. It's pretty straightforward if you know how to use the journal equation and find two equations and solving them simultaneously for solving two variables. The second part says find the 27th term, which is u27. Now this becomes pretty easy now because your journal equation is un equals to u1 plus n minus 1 into d. Now you already know your u1 is 19, your d is negative 3. And all you need to find is u of 27, which means your n is 27. Substituting all these variables here, you will get u of 27 equals to 19 plus 27 minus 1, and d is negative 3. So this is 19 plus 26 times negative 3. And if I do 26 times negative 3, I get negative 78. And simply adding 19 to it, I get negative 59. This is my 27th term. So things becomes pretty easy once I've found u1 and d. And the final part says find the sum of the first 27 terms. This is pretty easy as well because we have the 27th term. So the utility of the first formula is higher in this case, u1 plus un. So s of 27 is basically 27 over 2 times u1 plus u of 27. As I know, my u1 is 19, my u of 27 equals to minus 59. So S of 27 is basically 27 over 2. U1 is 19 minus 59. The plus minus becomes that. So just putting that everything in the calculator, 19 minus 59, multiply by 27, divide by 2, you get negative 540. So your S of 27 is basically negative 540, which means the sum of the first 27 terms is negative 540. You might wonder, why is the sum coming in negative? Because remember, we have the negative terms as well. And that's how, for example, our first term was 19, and we know that our 27th term is negative 57. So the negative numbers are more dominant in this case, and as a result, the overall sum becomes negative. So that's absolutely normal. Now let's try to solve another question, which is again a bit tricky but not difficult. It says find the value of k given the consecutive arithmetic terms. Now we know that these are consecutive arithmetic terms. So in order to solve this, we will use the property of arithmetic terms, which means the common difference is same as u2 minus u1 equals to u3 minus u2, and so on and so forth, any two consecutive terms. This is the property that we will use to solve this type of questions. So we know that our u2 minus u1 is going to be equals to u3 minus u2 in this case. This is u1, the second term, and the third term. We know that these are always going to be equal for arithmetic sequence. Now we can simply do this. So u2 is k, u1 is 3, u3 is 11, u2 is k. And it's simple, we just solve the algebraic equation. The only thing you need to know how to apply the property of arithmetic series in this case. So my k comes here, this goes there, so it becomes k plus k equals to 11 plus 3, so it becomes 2k equals to 14, and my k is basically 14 over 2, which is equals to 7. Pretty straightforward. In the b part, however, we'll use the same technique, which means u2 minus u1 equals to u3 minus u2. As you can see, this is u1, this is u2, this is u3. The question is same, but a bit of algebraic complexity that we can surely solve. So u2 is k plus 4. Always use brackets when you have more than one term in the algebraic expression. Minus bracket negative 2, because u1 is 2. u3 in this case is k squared plus 11 minus, and u2 is k plus 4. Now what's going to happen here, if you can open, this is k plus 4 plus 2 minus minus is plus. Open this as well, k squared plus 11 minus k minus 4. This is pretty much looking like a quadratic equation. So let's try to simplify it. K plus 4 plus 2, 6. K squared minus k, 11 minus 4 is basically 7. So bringing everything to one side, we have k squared minus k plus 7 minus k minus 6. Here we have 0. So we get k squared minus 2k, because minus k and minus k becomes minus 2k. 7 plus 7 minus 6 is basically 1 equals to 0. Now this looks like a pretty simple expression, quadratic expression, which we can use by factorizing, which will be explained in my quadratic videos. We can use the cross method, which means that first of all we multiply these two coefficients. This is 1, so 1 times 1 is 1. And then we just put this coefficient here. So basically try to find two numbers that multiply to the upper number, which is 1 in this case, and that add to the lower number, which is negative 2 in this case. So in this case, it's pretty straightforward. We can use basically minus 1 and minus 1. These are the two numbers. So minus 1 times minus 1 is 1. Minus 1 plus minus 1 is minus 2. So in simple terms, I can say k squared, I can just distribute my minus 2k as minus k and minus k plus 1 equals to 0. From here, I can take k common, it becomes k minus 1. Here I can take minus 1 common, it becomes k minus 1 equals to 0. Now you can see k minus 1 and k minus 1 can be taken as common. So k minus 1, and what is left is basically k minus 1 equals to 0. So this is the same thing basically. So I can say k minus 1 equals to 0, k minus 1 equals to 0. From here also I get 1, from here also I get 1. So which means my k is basically equals to 1. Now this is a quadratic equation which has one real root. We'll discuss these things when we study quadratics. Now let's look at the last question of this video. The first term of a finite arithmetic series is 18, which means my u1 is 18. The sum of the series is negative 210, which means s of n is negative 210. The common difference is negative 3, so t is equals to negative 3. It says that, suppose that there are n terms in the series, show that n over 2, 39 minus 3n equals to negative 210. Now we know that the sum of the series formula, we have two formulas, n over 2, u1 plus un, and also it's equals to n over 2, 2u1 plus n minus 1 into d. You can notice that we do not have the un term. So in this case, we do have u1 and d, which means this formula has more utility. So s of n is equals to n over 2, 2u1 plus n minus 1 into d. Now, I know that my u1 is 18, I know that my s of n is negative 210, and I also know my d is negative 3. All I have to do is substitute in this equation. And I said that before, that the nth term has to be with one variable, which is n. So s of n is negative 210, n will remain as it is, 2 times 18 plus n minus 1 into negative 3, which is b. Now be very careful because you're multiplying negative with these two things, so the signs would change. So negative 210 will be equals to n over 2. 2 times 18 is 36. Minus, because plus minus 3 is minus, so minus 3n, and minus minus is plus 3. And this remains as it is. The only simplification possible is 36 plus 3, which is 39 minus 3n, and this is exactly what you needed to prove. Now in the b part, it's saying hence find n, which means we need to solve for n. The very first thing we can do is simply multiplying this here, so to just get rid of it. So 210 multiplied by 2 is negative 420 equals to, and then n can be multiplied with both of them. So here it is 39n minus 3n squared. This looks like a quadratic equation as well. Now we can just simply move this thing here. This becomes minus 3n squared plus 39n plus 420, which is equals to 0. Now this can also be solved using calculator and quadratic formula, where my coefficients are 30 minus 3. This is your a coefficient, which is negative 3. Your b is 39, and your c is positive 420. By substituting it, you would see that you will get two values of n. n1 equals to 20 and n2 equals to negative 7. I told you that n cannot be negative because you cannot have a negative term. It means you can have a negative number, but you cannot have a negative term because the term always uses the first term, second term, third term. You cannot have a negative one term. So this is not possible. So n is 20, which means that the sum of 20 terms is negative 210. I hope you understood the video. If you have any questions, you can comment, and we will try to make sure that all your questions are being answered. The notes will be uploaded into our Google Docs, which the link will also be shared with you. All these notes will be available there. Have a great day. Bye-bye.